Hello, myself Dr. Sudha from Government Science College, Autonomous, Bangalore. In this session, let us see some problems on Euler's equation. For that, we need the prerequisites. Methods of solving differential equations is a must. Euler equation, that is the Euler equation dou f by dou y minus d by dx of dou f by dou y dash equal to 0, that you must remember. And three particular forms of Euler's equation, that is when the function f is independent of x, when the function is independent of y, and when the function is independent of both x and y, must be known to us to solve the problems on Euler's equation. So to begin with, let us take the first example. Find the extremal of the functional I equal to integral 0 to 1 12xy plus y dash square dx. Y of 0 is given to be 3, y of 1 is equal to 6. Now let us solve this. So first we need to write what is the given function. That is f of x comma y dash equal to 12xy plus y dash square. So this is the function given in the integrand. You need to take that as function f. So now look into the function f. Here function f contains x, y as well as y dash. Since it contains all the three variables, you need to take the Euler's full form. That is the first equation which we have derived. Dou f by dou y minus d by dx of dou f by dou y dash equal to 0. So this is the Euler's equation. Now we need to substitute here. So here f is known to us. So differentiate f partially with respect to y and put down the value. And dou f by dou y dash, that is the partial derivative of f with respect to y dash, need to be calculated. And you need to substitute in this equation. So what is dou f by dou y? So you partially differentiate this with respect to y. From the first term we get 12x into 1. So you get 12x. And in the second term you don't have y, therefore it becomes 0. So the partial derivative of f with respect to y is 12x. Similarly, you calculate the partial derivative of f with respect to y dash. So here in this expression for f, the first term doesn't contain y dash, therefore it becomes 0. But in the second term you have y dash square. When you differentiate this with respect to y dash, you get 2y dash. So after obtaining the partial derivatives, now let us substitute in the Euler's equation. So dou f by dou y is 12x minus d by dx of dou f by dou y dash, that is 2y dash, equal to 0. Now you differentiate this 2y dash with respect to x. Y dash is dy by dx. So you are differentiating y dash once again with respect to x. So you need to get y double dash. So you get 12x minus 2y double dash equal to 0. So here you can remove 2 common. So you get 6x minus y double dash equal to 0. Now you write this expression in the form y double dash is equal to 6x. So from here we need to solve for y. How to solve? Solve this differential equation which is of second order. So to obtain y, we need to integrate twice. So when we integrate once, we get y dash on the left hand side. 6x becomes 6 into x square by 2. So 2 and 6 gets cancelled and you get 3x square plus c, where c is a constant of integration. Now once again you integrate this. So y dash becomes y and 3 into x square, that becomes 3 into x cube by 3. So 3 gets cancelled and you get x cube plus c into x plus k, where k is a constant of integration. So this is the y value after integrating twice, but two conditions are given to find the two constants of integration, that is c and k. So the first condition was y of 0 is equal to 3. That is, when x is equal to 0, y takes the value 3. Put these values in the y expression. So you get 3 is equal to, wherever x is there you put 0 and wherever y is there you put 3. So you get 3 is equal to 0 plus c into 0 plus k. So you get 3 on the left hand side and on the right hand side you get k. Therefore k is equal to 3. Now let us use the second condition. Y of 1 is given to be 6. That is, when x is equal to 1, y is equal to 6. So in this expression of y, put y is equal to 6 and x is equal to 1. So what do you get? 6 is equal to 1 plus c into 1, that is c, plus k value is obtained in the first step. So you get k is equal to 3. So you get c value is equal to 6 minus 4, that is equal to 2. Put these two values of k and c in the expression for y. So you get y is equal to x cube plus 2x plus 3, which is the required extremal. Hope you followed this. Let us go to the next problem. Solve the variational problem. I is equal to integral 1 to 2 3x plus root of y dash dx, where y of 1 is equal to 5 and y of 2 is equal to 7. So let us see the solution. What is given? F of x comma y dash is equal to 3x plus root y dash. So this is the integrand given. Take that as function f, which is independent of y, because in this function f, y doesn't exist. So you have 3x plus root of y dash. Therefore, it is independent of y. Go to the Euler's equation, wherein it is independent of y. That is, dou f by dou y dash is equal to constant. Let us take that constant to be some k. Now let us substitute for dou f by dou y dash. That is, you need to differentiate this f with respect to y dash partially. So when you differentiate with respect to y dash, 3x becomes 0 and root of y dash gives us 1 over 2 root of y dash, and that is equal to k. Now let us solve this for y dash. So when we cross multiply and simplify, we get root of y dash is equal to 1 over 2k. Let us square both sides now. When you square both sides, you get y dash on the left hand side and on the right hand side you get 1 over 4k square. When you square 2k. Let us keep this entire constant on the right hand side as some c. So let us integrate that previous step, that is y dash is nothing but dy by dx. So on integration you get y is equal to cx plus some d, where c and d are constants. Now we need to find out these two constants c and d by using the given two conditions. The first condition says that y of 1 is equal to 5. That is, when x is equal to 1, y is equal to 5. Put those values here. So you get 5 is equal to c into 1 plus d. So we get c plus d is equal to 5. Let us call this expression as 1. Next, the second condition is y of 2 is equal to 7. That is, when x is equal to 2, we get y is equal to 7. Put these two values in this expression of y. So what do you get? 7 is equal to c into 2 plus d. So you get 2c plus d is equal to 7. Call this expression 2. Now there are two simultaneous equations, 1 and 2, in terms of c and d. So you can solve for c and d. So when you subtract one from the other, that is, when you subtract 1 from 2, you get c is equal to 2, and putting that value of c in one of the expression, you get d is equal to 3. So we got the value of c to be 2 and d is equal to 3. Put these two values in the expression for y. Y is equal to 2x plus 3. So you get y is equal to 2x plus 3, and this is the required extremal. So this is how you solve extremal problems. Depending upon the given integrand, you need to take the Euler's equation. Now let us move on to the third problem. Solve the variational problem, integral y dash square plus y square dx. Here only the integral is given, that is the functional is given, no other conditions are given. So it is enough if you solve for y in terms of the constants. So let us take f to be y dash square plus y square. Here when you look into the function f, you can see that it is independent of x because no x term is here. Since it is independent of x, we can take the Euler's equation as f minus y dash into dou f by dou y dash is equal to some constant. So let us take that constant to be k square. Why k square here? Because we get an expression in the form of the y square minus k, so we need to bring it to the standard integral form, so we take that to be k square. Even if you take k, you need to write root k whole square, no problem. You can take the value f, that is y dash square plus y square minus y dash into dou f by dou y dash. So when you differentiate this partially with respect to y dash, you get 2y dash and y square becomes 0 and it is equal to k square. Now you simplify. There are two terms in y dash. Here you have y dash square and here you have minus 2y dash square. So on simplification you get y square minus y dash square is equal to k square. Now you need to solve this for y dash. So shift the terms to the other side, you get y dash square is equal to y square minus k square. So when you solve for y dash, you get that to be equal to root of y square minus k square. So now what is y dash? It is dy by dx. So dy by dx is equal to root of y square minus k square. So separate the variables here. When you separate the variables, you get dy by root of y square minus k square is equal to dx. Now on integration, so we get integral dy by root of y square minus k square equal to integral dx plus a constant of integration c. So the left hand side is in the standard integral form, that is integral dx by root of x square minus a square, and that is nothing but cos hyperbolic x by a. So here instead of x and a, here you have y and k. So you get cos hyperbolic inverse y by k equal to integral dx is equal to x plus c. So let us solve this for y. So when you solve this for y, you get k into cos hyperbolic of x plus c, and this is the required extremal. Here no other conditions are given to find the constants c and k. Therefore, you keep the solution as y is equal to k into cos hyperbolic of x plus c, and this is the required extremal. Hope everybody followed how to solve these extremal problems. So there are some more problems here. I have noted down here. There are nearly 12 problems. So you can solve all these 12 problems, note down these problems and solve one by one.